Today we will discuss on limitations of physical analysis, dimensional analysis, not physical analysis, dimension analysis. Okay, so before going to discuss that, we will just look at classification of physical quantities. Okay, so in previous videos we have already discussed on physical quantities. Okay, but we will discuss today physical quantity on the basis of dimensional formulae. Okay, on the basis of dimensional analysis. Okay, and on the basis of that, it has four categories. Okay, we can see here four categories: dimensional variables, non-dimensional variables, dimensional constant, and non-dimensional constant. Okay, so dimensional variables are physical quantity which have dimensions. Okay, so many physical quantities are there which have uh, di- uh, dimensional formulae. Okay, examples are given: area, volume, velocity, force, coefficient of viscosity of a liquid, and many more. Okay, so this is the general condition, general category. Okay, we know if there is a physical quantity, they will have unit, and therefore they will have dimensional formula also. Okay, but some physical quantities are there which don't have dimensional formula, and that is second category. Okay, so angle is a physical quantity, but it does not have any dimensional formula. It has unit, it has unit radian. Okay, but it don't have any, does not have any dimensional formula. Specific gravity is also known as relative density. Okay, it is unitless, and therefore it does not have any dimensional formula. Strain is a unitless quantity, and therefore it don't have dimensional formula. Okay, so this is these physical quantities are very important by keeping examination in mind. So examination point of view, these are very important terms, and 1 marks question are asked which are based on these physical quantities. Okay, sometime it is asked that what is the dimensional formula of angle. We know the unit, but we don't have dimensional formula for it. A specific gravity, which is also known as relative density, don't have any physical, sorry, dimensional formula. So these are important physical quantities. Okay, so learn all of them. Third is dimensional constant. Okay, so whenever you are discussing dimensional formula, if it is in your mind that constant don't have dimensional formula, then it will be wrong. Okay, constant means, first of all, you must have known which type of constant are discussing about. Okay, so some constants are written here which have unit, and if they have unit, they must have dimensional formula. Okay, for example, gravitational constant. Okay, so it is constant, but it has dimensional formula. Gas constant, or it is a constant but it has dimensional formula. Planck's constant, it has dimensional formula. Okay, so remember all those physical constants, remember all those terms. Okay, because these are very important for examination point of view. Okay, so these constants have dimensional formula. Okay, learn all the dimensional formulae for these constants. Understood? And non-dimensional constant are those numeric terms. For example, 1, 2, 3, pi, these are pure numbers, and therefore they don't have any dimensional formula. Understood? পাখাটা খুলে দাও। ইনভার্টার আছে না, উপরের পাখাটা খুলে দাও। আর কথা বলবা না এখন। Now we are going to discuss dimensional analysis. Okay, so uh, limitations. Okay, so first limitations is information about dimensionless constant and pure number. Okay, so suppose if any relation, any expression you cannot find with the help of dimensional analysis, that what will be the numeric value of the given term. For example, we discussed t is equal to k under root l by g. Okay, we have discussed in the previous video that we have this relation. Okay, but k is a term which is constant. Okay, and by the help of dimensional formula you cannot find the value of k. You can find out k is equal to 2 pi by calculating terms or by experiment, which is equal to 2 pi, k is equal to 2 pi, but with the help of dimensional formula you cannot find it. So this is one term. Okay, one point which is limitation of dimensional analysis. Second one, it fails to derive the exact form of physical relation which depends upon more than three quantities. Okay, so if any physical relation, any expression is there, suppose a is depending on b power a, c power b and d power c. So three terms are there. So if fourth term will come which depends on a, or a depends on the fourth physical quantity, then dimensional analysis will fail to find out the relation. Okay, so it is valuable till three physical quantities. ठीक है, come to next. Third is, the method cannot be used for deriving relation involving trigonometrical or exponential functions. Okay, so it is correct. If the relation has any, the expression has any term which includes trigonometric functions, sine, cos or tan, okay, then this physical analysis is not able to find out the relation, because it is fail for the terms which are exponential, which are trigonometric. Understood? Come to next. The method of dimensions cannot be used to derive the exact form of physical relation if it consists of more than one term. Okay, yes, we already discussed that s is equal to ut plus half at square. Okay, so s is depending on velocity, s is depending on time, and s is depending on acceleration. Is that clear? So if the question would be given like this, distance is depending on u, that is velocity, time, that is t, and acceleration symbolized by a. Okay, so if it is given in the question, can you find the relation or can you find the expression for these physical quantity in the term given in the equation, ut plus half at square? No. So that means if this is given, you can find out the relation which consists of one term, but in the given equation that we have written as is equal to ut plus half at square, it consists two term. In one term it is ut and in second term it is half at square. Okay, but by dimension analysis you cannot find the expression or relation or equation in the given manner, because it consists two terms. Okay, therefore the dimension analysis is not capable to find such equation, to derive such equation. Understood? Come to next. The method fails. Fifth point, the method fails to derive the relation which contains two or more variables having the same dimension. Yes, suppose you have a relation a is equal to b by c. Okay, so b is a physical quantity that has uh, the same dimensional formula with the dimensional formula of c. B and c has the same dimensional formula. Then dimensional analysis is failed to find such kind of relation. Okay, in my mind a relation is coming for such example. Suppose we are taking relative density, okay, which is also known as specific gravity. Okay, so relative density is equal to density of the material, okay, upon density of water. This is the formula to find out relative density. Density for any material or any substance, and density upon density of water. So it is density, numerator, and denominator is also density. So it will have no any dimensional formula. It will not have any physical unit, any unit. Understood? Therefore relative density don't have any unit. But can you find the relation, this relation, with the help of dimensional analysis? Okay, no, the answer is no. So this is one of the limitation. Next and last, the method enables us to check only the dimensional correctness of the formula and not its overall correctness. Yes, we know that if we are writing t is equal to 2 pi under root L upon G, this is the exact formula to find out the time period of a oscillating pendulum. Okay, this is the real formula, exact formula. Okay, but if I will write in place of 2 pi, if we are writing 4 pi under root L upon G. Okay, the dimensional analysis is failed to differentiate both of the relation. Why? Because it will give the same dimension as the last one gave. Understood? Means dimensionally it, this one is correct, and dimensionally this one is also correct, but dimensionally it is correct, not exactly it is correct, because exact is 2 pi under root L upon G. Okay, so this is one of the limitation of dimension analysis, that we cannot find the exact relationship or we cannot check the exact relation, we can check only dimensionally correctness. Okay, so this is for today, and this whole topic, limitation of dimensional analysis, is very important, and it has number of uh, numericals, number of problem based on it, and we will discuss on those problems. Okay, so write all these things and learn the examples which are given here, and till the next video, bye.